Hey guys, welcome to my YouTube channel. In today's video guys, I'm going to be taking you guys through on how to determine the numbers of steel reinforcement lengths in a tonnage of 3 different sizes of rebar. So shall we get started guys? Let's go. Before I proceed guys, I would like to give you guys a clear insight, a clear definition of what rebar means. Rebar basically is used in construction for the construction of structure such as bridges, buildings, warehouses, skyscrapers, foundations, basically to increase the tensile strength of concrete structure. Having known this, why do we use rebar alongside concrete in construction? The main reason why we use rebar alongside concrete in construction is basically because concrete itself is weak in tension but strong in compression. So using rebar alongside concrete tends to resist tensile stresses, causing bending moment from applied loads, which of course in future brings about ultimate failure and cracking. Having said this, what are the different sizes of rebars that we have? The different sizes of rebars that we have are 6mm bar, 8mm bar, 10mm bar, 12mm bar, 16mm bar, 20mm bar, and so on and so forth. But in today's video guys, I'll be taking you guys through on 3 different sizes of rebars among the listed, which are 10mm bar, 12mm bar, and 16mm bar. Of course, how to calculate the numbers of steel reinforcement lengths that makes up the tonnage of all these 3 different sizes of rebars. So now to start with guys, I would like to start with 10mm bar, calculating for the numbers of steel reinforcement lengths that makes up the tonnage of 10mm bar. And how do I do this? The first thing to do here is calculate the weight of a single bar of 10mm. And how do I calculate the weight of a single bar of 10mm? There is this particular formula that we use, which is d squared multiplied by L divided by 162, where our d is the diameter of that steel reinforcement bar we want to make use of, which is of course 10mm, and our L is the length of the steel reinforcement, which is a constant 12 meter. Knowing this, all we have to do is input our figures in the formula, and after doing this, all we have is 7.41 kg for the weight of a single bar of 10mm. Note this guys, for every 1 ton, 1000 kg makes up a ton. So now, how do we determine the numbers of steel reinforcement length in a tonnage of 10mm bar? All we have to do here is divide our 1000 kg, we divide it by the initial value we had for the weight of a single bar of 10mm, which was 7.41 kg. And after doing this, all we have is 134.9 numbers of steel reinforcement length in a tonnage of 10mm bar, which is approximately 135 numbers of steel reinforcement length in a tonnage of 10mm bar. So now moving forward to 12mm, determining the numbers of steel reinforcement length in a tonnage of 12mm bar. So like we did for 10mm, all we have to do here too is calculate the weight of a single bar for 12mm. And how do we do this? Our formula here still remains the same, like 10mm, which of course we know that the only thing that is going to be changing here is our d, the diameter, which is of course 12mm this time around, and our L, which is the length, still remain a constant 12 meter. Knowing this, all we have to do is input our figures in the formula, and after doing this, all we have is 10.67 kg for the weight of single bar of 12mm. After doing this, we will move further to determine the numbers of steel reinforcement lengths in a tonnage of 12mm. And how do we do this? Like I said, 1000 kg makes up a ton. All we have to do here is divide our 1000 kg, we divide it by the weight of a single bar of 12mm, which we had initially to be 10.67 kg. And after doing this, all we have is 93.8 length of steel reinforcement that makes up the tonnage of 12mm bar, which is approximately 94 numbers of steel reinforcement length that makes up a tonnage of 12mm bar. Having said this, I will move forward to 16mm in determining the numbers of steel reinforcement length that makes up a tonnage of 16mm. How do we do this? Still the same procedure. Our formula here still remains the same, and all that is going to be changing here is our diameter, which is of course 16mm this time around, and our L, which is the length, still remain a constant 12 meter. Knowing this, all we have to do is input our figures in the formula to calculate for the weight of a single bar of 16 mm. And after doing this, we will have 18.96 kg as the weight of a single bar of 16 mm. So after doing this, we move further to determine the numbers of steel reinforcement length that makes up a tonnage of 16 mm bar. And how do we do this? Like I said, 1000 kg makes up a ton. All we have to do here is divide our 1000 kg, we divide it by the numbers of the weight value of steel reinforcement of single bar we had for 16 mm, which was 18.96 kg. And after doing this, all we have is 52.7 numbers of steel reinforcement length that makes up a tonnage of 16 mm, which is approximately 53 numbers of steel reinforcement length that makes up a tonnage of 16 mm bar. So thank you guys for watching my video to this moment, and I hope you guys find it so helpful. If you find it so helpful, you can help me like, comment, share, and most importantly, subscribe to my YouTube channel so as for you to get notified anytime I drop another video of mine. Thank you guys. Peace out.